Welcome back, guys. Okay, so we're going to start off this lesson with a question of finding the area of the region bounded by the curves y equals sine of x, y equals cosine of x equals 0, and x equals pi over 2. So, as you can see, I have drawn the cosine and sine graphs. I drew them from 0 to pi just to get you a look. But remember, we said we wanted the bounds from x equals 0, which, you know, is right here, up until pi over 2, which is here. So if we're looking for the area bounded between these regions, that actually comes down to this area and this area. Notice our normal formula for this is top minus bottom, but at their intersection, you can see that shifts, right? For the one, it starts cosines on top, sines on the bottom, and then it changes to sine on top, cosine on the bottom. So to actually solve this, you may be thinking, oh, we need to set up some integral of top minus bottom, but that's tough to do when this happens in two separate intervals. So the notation for this is we could go from 0 to pi over 2 of cosine of x minus sine of x. And they say the absolute value of all of them, dx. But really what that means is we can split this interval up into two separate intervals. I'm thinking I want 0 to pi over 4. That's where they cross initially, because that's where sine equals cosine is at 45 degrees, pi over 4 radians. And on here, for this first area, notice green's on top, purple's on bottom. So that's going to be cosine of x minus sine of x. We're going to add to that this second area, the second kind of interval here, which is from pi over 4 up to pi over 2. Here, it's sine over cosine. So it's sine of x minus cosine of x. And at this point, it's just going through and getting this work done and seeing what we're getting here. The hard part here is really the setup, right? Identifying that this is on top, that's on bottom for this interval, and that's what we have here. If we're actually going through and doing this, the integration here isn't all that tricky, right? Sine of x here, the antiderivative of negative sine is going to get us, well, positive cosine even. So here we're evaluating from 0 to pi over 4. And now we're integrating this bit, and this is going to be negative cosine of x. Integration is a negative sign, excuse me. Pi over 4 to pi over 2. Evaluating this stuff, I know this is everyone's favorite. Sine and cosine of pi over 2 is root 2 over 2. And then we're subtracting 0 plus 1. That's this first bit. So we really just have here root 2 minus 1. Over here, we're going to go through. And as you go and do the same thing here, we get what? 0 minus 1. And then here, we're going to be subtracting. And for our pi over 2 and pi over 4, so now we're pi over 4. We have what? Negative root 2 over 2 minus root 2 over 2. And with this double negative, here we're getting root 2 minus 1 as well. We add both of those to root 2 minus 2. So the math itself isn't all that hard. It's the setup that's initially hard. They deem it this absolute value, but I think the way to think about it is still just sticking with our top minus bottom. Okay. Let's look at a different type of question that we're going to have for homework here specifically tonight. The 4 I'm going to assign for us look like this. So the area enclosed by this line y equals x minus 1, which is just this line going up here. It would help if I wrote the right one. I have x equals y equals x, but it's x minus 1. And then for the other one, it's y squared equals 2x plus 6. If you're like, I never would have known how to graph that, my thought there, the squared is indicating it's some parabolic form, specifically sideways. And if you just square rooted it, I think it's like plus or minus. So we know the square root of 2x plus 6 is this kind of square root function, and then it does the same thing on the bottom. And I know it's at -3 because we plug -3 in here. That gets us 0 for y. So that's kind of the parabola we have. They do cross at 5, 4, and -1, 2, which you can go through and check out if you set them kind of equal to each other. If you're like, how do you set these equal? They're completely different things. We know y squared equals all that, so y here. So we know x minus 1 squared is the same as y squared. That should equal 2x plus 6. Solving this, we get x squared minus 4x. What's that? Minus 5. X equals 5, x equals -1. And if you plug these back into either equation, obviously this y equals x minus 1 is the easier. So you subtract 1 here. So it's y equals 4 there, and y equals -2. So you knew they crossed at 5, 4, and -1, -2 to help us with this picture if you didn't have that established right away. Okay, either way, for this we're thinking top minus bottom, correct? And if we're thinking top minus bottom, this y squared equals 2x plus 6 is on top. But the issue becomes, think if we're going top minus bottom, just even following the lines of the graph. That's on top. On bottom is the x minus 1. As we're going along, that's all good until we reach here. All of a sudden, there's that breaking point that's happening here. And then notice this one function is both the top and bottom function here. That becomes potentially an issue. So that means the two areas we're looking at are like this green area and then this like purple stretch. So if we were setting this up for the green area, notice it's -3 to -1. The top function is the square root of 2x plus 6. And we would be subtracting this bottom function, which is actually, remember, the negative version of this. So we'd be subtracting the negative version of 2x plus 6. Which, you know, altogether simplifies to this. It's just two of them. And this is going to involve some u sub to solve. If we're looking at the purple bit next to it, that's from -1 up to 5 for our x values. That's the square root of 2x plus 6 minus the bottom function, which is x minus 1 that we'd have to go through and do. And no real nice way to write all this out. I'm looking at this, though, initially and thinking, this is a bear. You can go through and use sub both of these, go through and solve these. But this isn't really pleasant, and it's easy to miss this like green-purple split that we have here of what functions what. So mathematicians, when they saw this initially, thought there's got to be a better way. And what do you know? There is. So you're all going to get frustrated. But if you redraw your picture, or maybe just look at your picture differently and see what I'm doing, I've redrawn one over here. And instead of thinking it from this perspective, we're literally going to change the way we think about this question. Kind of tilt your head sideways. Remember, this was our y, this was our x. But if we tilted this way, our perspective now was with respect to y. And if we're thinking top minus bottom here, isn't this one function on top the entire time, no matter where you draw your line? The linear function's on top and the parabola's on the bottom. Ooh, 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 this is great. So we can set up and solve this. But now we're with respect to y because we've turned it this way. So think about it. In this direction, we're with respect to x. If we can turn the function this way, we can be with respect to y. So that means all the things in here, we'd like to have y values in them. So that means you need to solve these equations for x equals. The linear function, if you remember, was here. So solving for x equals That's y plus 1. The bottom function here, we said was what? Y squared equals 2x plus 6. If we're solving this one, we subtract the 6 and divide by 2. That's what this bottom function is. X equals y squared over 2 minus 3. So we now have, a top function and a bottom function to subtract. Our top function is y plus 1. Our bottom function that we're subtracting is y squared over 2 minus 3. Now remember, we're with respect to y. So looking here, we mark these points. What is the smallest y value? So think here, we have 4 as a y value, 0 as a y value, and we said -2. So -2 is our smallest y value, and we're going all the way up until we hit to our largest y value, which is 4. So yeah, this might be worth going back and looking at again. This kind of turning is kind of a very intricate thought that is worth really going through and doing out. If we're combining like terms, we have a negative y squared over 2. We have a y, and then we have 1 plus 3, which is 4. So I believe that's the function we should look at. And at this point, we're going to go through, integrate here. -1/6 y to the third plus 1/2 y squared plus 4y from -2 to 4. We're plugging these numbers in. This is 64, 16, that's 8. This is a 16, and we're subtracting. This is going to end up being 4/3 plus 2 minus 8. We go through and do all this arithmetic. This is coming to 18. So this is a lot easier than doing the u sub that we would have had to do over here. If you'd gone through and done both these integrals, done the arithmetic correctly, you would have also arrived at an answer of 18. Okay, we ran a little long here. Our homework tonight, we're looking at a couple with respect to y. We're still in 6.1. We're doing 3, 4, 11, and 12. Okay, good luck, guys. See you tomorrow.